Hey, ladies and gentlemen, I'm honored to be the host of the conference this morning. And this morning, altogether, we have 3 plenary speech speakers. Tiago Torrent from Federal University of G4, and another one is Professor Liu Zhengguang from Hunan University, and Professor Deng Yunhua from Hunan Normal University. And next, I just give a very brief introduction to Tiago Torrent. Tiago Torrent is a professor of linguistics at the Portuguese Language and Linguistics Department of the Federal University of G4 in Brazil. He earned a doctorate degree in cognitive linguistics from the Federal University of Rio de Janeiro, with a visiting researcher period at the Linguistics Department of the University of California, Berkeley. Since 2010, he is ahead of the FrameNet Brasil Computational Linguistics Lab, conducting research on natural language understanding with semantic frames and grammatical constructions. He is also one of the founding partners of the Global FrameNet Initiative and has been recently awarded a Brilliant Language Technology and Innovation Prize by Brazilian Linguistics Association. This morning, he will share with us his recent research. The title is Collaboration is All You Need, applying for multilingual, multimodal, and multicentric FrameNet. Now, let's welcome Tiago Torrent.
Thank you very much, Professor Chen, for the introduction. I'd like to take this opportunity to thank the Center for Cognitive Science at the Hunan Normal University for inviting me for this great conference, and say good morning to all of our audience, both here in Zoom and Bilibili. So I'll be sharing my screen with you to start the presentation. So, okay, so I guess you all see my screen now, right? As Professor Chen said, the title of my talk, the talk that I prepared for today, is Collaboration is All You Need, a plan for a multilingual, multimodal, and multicentric FrameNet. The idea in this talk that was summarized in this Hyperloop pitch, a shorter, more technological version of an elevator pitch, is that the tension between large language models and structured language resources, on the other hand, is not irreconcilable, provided that we reframe our views on both of them. And this is what I want to convince you of throughout this talk. So let's start with a very brief overview on large language models. So large language models, usually named after Sesame Street characters such as BERT, or acronyms such as GPT-3 or GPT-2, are built based on 3 requirements. So first of all, they require very big data. They require training to be performed on this very big data, and then they should be fine-tuned for some downstream task. because of the fact that they can be fine-tuned for several different tasks. And if we're talking about language models, those tasks currently include natural language generation, they include machine translations, text summarization, question answering, so on and so forth. They have been called foundation models recently. So there is a paper by Bomassani et al. That was published this year called On the Opportunities and Risks of Foundation Models that provides a roadmap saying how machine learning got to this point where those models are built, and they are not built only for language. They are built, for example, for vision, for computer vision downstream tasks as well, and also for a combination of both. So currently we have applications on multimodal machine translation, for example, or multimodal fake news detection, and a series of other tasks. They do achieve state-of-the-art performance in a series of tasks, among all of those that I mentioned and some other ones, according to a set of metrics. So for example, glue and superglue or clipper are standardized metrics that are used to measure the performance of any kind of application in natural language processing or natural language understanding, and large language models have been constantly beating state-of-the-art in those tests according to those metrics. But another very recent paper that has just been presented at a NeuroIPS conference this week by Raji et al. Question whether those metrics actually measure performance in natural language understanding. And the reason why they question that is because metrics such as glue, for example, they pinpoint a series of expected results or expected responses, but the fact that usually those metrics are taken as evidence or as unquestionable evidence that a given language model achieves state-of-the-art performance in natural language understanding bears a very big problem. Because when we say natural language understanding, we are somehow referring to a general capacity, while those metrics tend to measure very, very specific performance on a given data set, and not even on a given task, but on a given task as evaluated against a given data set. And this is a very reductionist perspective on what natural language understanding actually is. And to provide you an example of the kinds of issues that we have, I chose a very recent model. It was launched by the AI2 Institute in November this year. And the name of the model is Delphi. So Delphi is, and this is quoted from their website, is a research prototype designed to model people's moral judgments on a variety of everyday situations. So it's a demo, and it shows the abilities and limitations of those state-of-the-art models today. So the idea of Delphi is that you can ask moral questions or moral judgment questions or ethical questions to the model and get the answer. This model is trained on a series on a data set that was built from crowd workers, answering questions about morality judgments, and the model extrapolates those answers for questions it may have never encountered before. So to test this, I used a very, very famous example of frame semantics. And this is sometimes referred to as the Boston trial example. So George Lakoff tells the story of when he started thinking about frames as a means of representing cognition. And he reports that he was talking with Chuck Fillmore, the founder of frame semantics and of FrameNet. And Fillmore told him about a trial that was being held in Boston back in, I think, 1977. And a doctor was being prosecuted for having performed an abortion procedure on a patient. And that was a very audience driving trial. So there was a lot of pieces on the news outlets on this Boston trial. And one thing that grabbed Filmer's attention back then was that prosecutors, the accusation attorneys, used the word baby every time they referred to the abortion procedure, while the defense attorneys used the word fetus. The thing is that baby evokes a scene, which we call a frame, that is more grounded on this idea of a family member, of someone that you care for example, while fetus is more related to a medical domain set of frames, right? So it's a more familiar perspective in the first case, and in the second case, it's a more scientific view on the fact. So I decided to test whether changing those words would affect the moral judgments produced by Delphi. So I asked Delphi, should the fetus be aborted because of serious genetic condition? And Delphi speculated and responded, it's okay. So when I changed the word fetus by the word baby, and asked the same question, should a baby be aborted to a very serious genetic condition, then the answer was consistent. So it's okay. So when we look at those answers, we linguists tend to think that the reason why they are the same is because of the presence of the predicator aborted. And this is so because this predicator is itself from a medical scientific domain. So to test again, what I did was that I changed the verb and asked, should a baby be killed because of a serious genetic condition? And then Delphi answered, it's wrong, right? So by testing that, the impression that I got, or as a linguist that we see, is that my first hypothesis was correct. So killed here changed somehow inside this black box model, how it ponders about this moral question. So just to double check, what I did was to ask whether a fetus should be killed because of a serious genetic condition. Because if the main verb here is the key to this answer, then the answer would be it's wrong. But the answer is it's okay. So when we compare those two questions, what we see is that contrary to the expectation of most linguists that rely on the power of main predicates to define the semantics of a sentence, here the nouns would be changing the perspective, right? As Fillmore reported back in 1977 when he first told about the Boston trial to George Lakoff. But the question here is, we actually don't know why Delphi answers like that. And that is one of the biggest issues that current scholars relate to large language models and the way they are built. So there is a very, very famous paper published this year on the dangers of stochastic parrots by Emily Bender, Timnit Gebru, Megan Mitchell, and other collaborators that points out that large language models have risks. And basically because they're trained on limited data, they end up encoding harmful social biases. Okay? So now to an overview of curated language resources, but well, since I built one of them, which is FrameNet Brazil, I'm going to give you a FrameNet perspective. So since the very beginning of my experience with FrameNet, which is now 11 years old, I always heard the same issues and the same questions about building a FrameNet. So basically, they all relate to the requirements of building a FrameNet. So it's common sense knowledge that to build a FrameNet, you need highly trained people. And traditionally, people who started FrameNets from the original Berkeley model have been trained by Berkeley people at the International Computer Science Institute. That was, for example, my case and the case of Professor Kyoko Ohara from Japanese FrameNet, and Professor Li Ru from Chinese FrameNet, who spent some time in Berkeley as well, and also from Carlos Subirats for Spanish FrameNet, and everyone in the Salsa project, and so on and so forth. Also, you need an analytical framework. In the case of FrameNet, this analytical framework is frame semantics. And then, of course, in the case of WordNet, it's a different analytical framework, but we need some sort of linguistic grounding to build a language resource. And then from this analytical framework, you must devise a database structure that properly represents how this theory can be applied to the computational domain, how it can be implemented. So, and because of the nature of those requirements, there is a very famous quote by Professor Valeria de Paiva in a paper at LREC 2018 that starts with, linguistic resources are very easy to start working on, very hard to improve on, and extremely difficult to maintain. And the reason why she says that, quoting a former boss she had on an IT company, is because usually the funding goes to the new language resources. So maintaining them and keep producing them is very hard in this model. To give you an example of what a frame is in FrameNet, I took this picture from Rio. And here we can see that, well, this is a place, right? I can see there are buildings there and mountains and a beautiful skyline. For those of you who are familiar with Rio de Janeiro, here we have its most famous attraction. It's the Christ the Redeemer statue from the Corcovado Hill. It's now, the photo was taken from the Sugarloaf Hill opposite to the Botafogo Bay. And we can see some tiny tourists on this side, right? So in frame semantics, I can say that the scene is a frame. It has participants, the attraction, the place, the tourists, but also it has a perspective. So if I'm looking at the scene from the perspective of the kids, the tourists, I can say that this is the touring frame because the tourist is the point of reference for establishing the perspective. But on the other hand, if I take the perspective of the Christ the Redeemer statue, then I change the frame to attracting tourists because that's a different perspective on the same scene. So we can define those frames and say that in the touring frame, a tourist experiences a specific attraction, a specific place with a unique history or the socially recognized individual character with the goal of seeing and learning about it. And because frame semantics is a theory of lexical semantics or was born as a theory of lexical semantics, I can say that there are words such as the verb do or the noun tour in English that evoke the scene, right? The same goes for attracting tourists. Then I can say that either a place or an attraction has culturally and or historically recognized natural or artificial resources which attract tourists from different places. But for this perspective, the lexical items are no longer do or tour, but they are attraction, the noun, or draw, the verb. And when we bring this notion of frame semantics into FrameNet, what we do is to build a network of frames as a model of linguistic cognition to account for the meaning of the lexical units. And then we annotate corpus to attest the proposed analysis in those frames. So for example, this is how the Turing frame looks like on the FrameNet Brasil database. You see that each of the elements are defined as core frame elements because they are mandatory for this Turing frame to be instantiated. And there is a definition for the frame, and there is also a definition for the frame elements. But because it's a frame net, not a frame list, those frames are interconnected in a network of frames. So I can say that both Turing and attracting tourists down to the center are connected to attraction tourism via this pink arrow that encodes distinct perspectives. And this blue arrow connecting attraction tourism to tourism scenario stay models the fact that when a tourist is staying at some place, this tourist may engage in touristic activities that are driven by the existence of an attraction, right? So this is how we model frames and networks of frames in a FrameNet. And then we can annotate corpus. So for example, if I have a sentence like, back in 2018, we did the historical cities of Minas Gerais, I can annotate that we represents the tourists, the historical cities is the attraction, and Minas Gerais is the place. or I can annotate in Rio, the place most foreigners, the tourists, do the Corcovado attraction tour, and tour is the lexical unit evoking this frame. Okay? So when we have this overview of large language models to one side and language resources, curated language resources such as FrameNet on the other side, we get to this tradition of looking at those things as representatives of a irreconcilable dispute. But is it really, right? So this dispute usually comes or surfaces in sentences like this. You know, large language models encode harmful biases because they are trained on raw data, and you cannot control the data, and you cannot assure what the outcome would be. On the other hand, people say, you know, curated language resources are very expensive to build and very time consuming. But then someone could say, but large language models exclude language varieties because they are trained on limited data and cultural perspectives, for example, within a same language. On the other hand, people say, okay, maybe resources could deal with that, but you know, they have so little coverage, and then it's a problem. However, the question that keeps bugging me from the past 5 years is, but what if we reframe what we mean by language resources? What if there's another way, for example, of building a FrameNet? And that's what I've been investing my time in recently. So as promised in the abstract for this talk, my idea is to present a plan for building a multilingual, multimodal, and multicentric FrameNet. So the step one of this plan is precisely to make FrameNet multilingual. This idea is not brand new. It actually started 5 years ago, back in 2016, when Berkeley FrameNet got funding for aligning existing FrameNets for several languages. We had a international FrameNet workshop held here in Juiz de Fora, in Brazil. And from that workshop, the idea of building a global FrameNet was born. Global FrameNet is a hub for fostering collaboration in the development of frame-based language resources and applications, and it provides for participating teams in this effort with software infrastructure, learning repositories, and shared tasks. Everything is freely available at globalframenet.org. And the shared annotation task, which was devised in 2016, aimed to analyze how well Berkeley FrameNet, so the original English frames, can be used for different languages. You know, we, and I am included, so the people who started their own FrameNet labs around the world, we have always been focusing from the very beginning on the differences that would arise from the fact that, you know, Japanese encodes this semantic information differently, or Brazilian Portuguese does not lexicalize this concept like that. But what we wanted to do was change this perspective or reframe the way of thinking, and then get one same text, which was TED Talk, the most viewed of all times, Do Schools Kill Creativity by Sirkin Robbins. It's also the most translated TED Talk there is from more than 80 languages. And we decided to annotate this TED Talk for several languages using only Berkeley FrameNet frames. We were allowed to create new lexical units in our own languages, but not to change the frames. But wherever there was a problem or a need to adapt the frame, we would note it in a parameterized way, so it could be extracted as an information. So here is an example screen of one of the first sentences in the TED Talk. So it's, I have an interest in education. This is also annotated. It's annotated for the interest noun in the emotion-directed frame in English. So you see that I is the experiencer and in education is the stimulus. It's also annotated for Swedish. Jag är intresserad av utbildning. And we see that the adjective intresserad evokes the experiencer focus frame in Swedish, but in Portuguese it's a verb. It's interessar-se. So due to those lexical distinctions, what we see is the mental stimulus experiencer focus frame. So what we wanted to do with this task is to have one same text annotated for very different languages. And here we have our report as of yesterday. So we have 1,400 annotation sets for German, 800 for Greek, 1,400 for English, and 1,400 for French and French Canadian with almost 1,000. And there are also Hindi, Japanese, Brazilian Portuguese, Swedish, Urdu, and so on, and some beginning of Chinese, and so on and so forth. So to make it possible, what we needed to do was to develop a new annotation tool, which is the FrameNet Brasil web annotation tool. We built this software tool here in the FrameNet Brasil lab, and we distributed it freely for all the participating groups and also for people who wanted to start their own FrameNet initiatives. The reason why we needed to do that is because the original Berkeley tool, it's a desktop tool, required a sort of infrastructure that you would pretty much only find in the International Computer Science Institute in Berkeley. So this first step to make it possible for other labs to start their own FrameNets was precisely to build a new tool and provide them with it for free. Step 2 of the plan is, of course, to make it multimodal. We all know, so this is pretty much preaching to the choir, that human communication is inherently multimodal. But because of that, the semantic representations we built for human communication should also be inherently multimodal. So we developed a multimodal module for our web tool. It starts with an import pipeline where you upload a video from your computer or get it on a video server. And then the FrameNet web tool gets the images on those in that video and the speech. And then we use a speech-to-text tool to transcribe the speech into a text file. And for example, we tested that with a travel show called Pedro Pelo Mundo, because this host, this guy, when talking to the camera, he speaks in Portuguese, but because it's a travel show abroad, so he visits several countries, when he talks to locals, he speaks in English, and we have, for example, Brazilian Portuguese subtitles. And we also get those subtitles and use an OCR software to generate text and then create a corpus for text annotation. So this is how it looks in the tool, right? So you have here the video, here the sentences that were transcribed, and we can merge the transcriptions together and build sentences for annotation. We also take the video frames and we run them from a machine vision algorithm that Mark mentioned yesterday. It's YOLO. And it draws the bounding boxes around the objects it recognizes. And so at the end, we have the transcriptions and all the timestamps, the subtitles and the timestamps, the objects that were detected and their classes. So if we take the very beginning of one of the episodes of this show, when the host is saying, when we think of Scotland, the first thing that comes to mind is miniskirt, Scottish whiskey, and bagpipe. And you see pretty much those images down here. We annotate the sentence for the frame. So primeira is first in Portuguese, so it's ordinal numbers. Coisa is thing, so it's entity. And viramente is come to mind, so it's cogitation. We annotate it all for frame semantics. And then we annotate the image as well. So here you see that bounding box 18 is annotated for people by origin frame, and bounding box 19 for clothing, and bounding box 20 for noisemakers, since it's a musical instrument. So by doing that, we are able to annotate not only text and build semantic representations for text, but also for everything that is going on top of verbal communication. So this multimodal annotation is carried out on another module of the FrameNet Brasil web tool called Karen. It's the first tool to allow for frame-based and fine-grained semantic annotation of multimodal objects. And then the step 3 in the plan is to make it multicentric. And the reason why this is key is because if we really want a curated language resources to be inclusive of different language perspectives, different cultures, and of different language varieties, for example, so that it could fill the gap left by large language models, we cannot be presumptuous to think that a small group of FrameNets will be able to do it, right? So we need to bring people in. And that's the idea of making it multicentric in the sense that every smartphone can be a contributor to FrameNet. So this is so because existing FrameNets capture only a small parcel of the vast possibilities of languages and language varieties. And motivated by this question of how can we make FrameNet reach its potential for representing meaning, together with the Red Hand Lab, with funding provided to FrameNet Brazil through the Annelise Meyer grant given to Professor Mark Turner, we developed the Lutma app. It's an algorithmic implementation of the frame creation process that everyone has been trained to make so far. And the idea is that users are guided through each step of creating a frame. There is additional structure to avoid redundancy in the resulting database. There are consistency and coherency checks throughout the process. And we encourage people to link the frames they create to the existing FrameNet database. So using this app, you could add lexical units to existing frames. So this is a snapshot of the screen. So for example, let's say that I want to check whether the LU hound exists in English as a noun for FrameNet. And then it queries the database and says, for example, that hound can be a synonym for dog in the animals frame and show this frame, right? And you can, for example, decide that you want to add this LU to this frame, and then you just provide a sentence to be an example of how hound would be used. But let's say that you want to add a new frame. So if you want to check whether there is a frame for robot in the English FrameNet, you will find out that there isn't. And then you decide to create a frame. And then Lutma asks what type of frame. And they say, okay, robots are entities. So this is a type of entity frame, right? So it's a frame that will be about a thing, a living being, or a concept, for example. And then you can enter the frame name. So I enter the automata name here. Then there is a check. So the tool checks for similar names and existing names, so you don't create a frame with a similar name. And then you add the frame definition, and then you save this frame definition. And then you can relate this frame to other frames in FrameNet. So for example, I want to say that automata is a kind of entity. So I'm going to use the inherit relation in FrameNet for that. And then I can say that the constituent parts of the entity will map the constituent parts of the automata, and so on and so forth. And that the name of the entity will map the name of the automata, but that the entity frame element is going to be more specific, and then it's going to be replaced by automaton. And also I can say that instead of being a type of entity, it's going to have a function because it's a robot that does something, for example. And then I could add new frame elements, right? So I can choose whether this frame elements that I chose to inherit from are core or peripheral frame elements. They're mandatory or not for this frame. I can add definitions for those elements and save them. And then based on all the existing entity frames in the Berkeley FrameNet and other FrameNet databases, the tool can suggest frames that are frequent in the entity type of frame with their definitions, and I can choose the ones that I want. I can add frame element to frame element relations the same way it happens in FrameNet. And in the end, I have the chance to review everything, edit what I want, and save the frame. In the very moment that I do it, that I save this frame, it's already included in the global FrameNet database. But the tool is not only about creating the frames, it also teaches you how to do it. So there is a set of tutorials of 3 types: coach cards, text tutorials, and video tutorials. So coach cards are short texts that focus on how to use the app and are shown to the user only at the first time they reach a given function here. So you have the quick preview, and then click on an LU for a preview of the frame description. We have the text tutorial. So when you say enter lemma and you click a question mark, you get the tutorial for this part of the process, just to provide the user with all the information they need at that moment. And if they want to learn more, then we recorded a set of video tutorials about all the key aspects of FrameNet, and they are 3 to 9 minutes long, and people can watch them while they are doing the process. So to summarize, the plan that we've been pursuing in a nutshell is based on the fact that we believe that FrameNet can be used together with large language models if we reframe our perspective on both of them. So that first, more languages and language varieties are included. Second, other semiotic modes such as video and pictures and maybe gesture are analyzed. And third, more people can contribute their perspectives to the model. To achieve this goal, what we need is software tools built for multilingual and multimodal analysis. We have those in the FrameNet Brasil WebTool. Software tools for collaborative FrameNet building, we have it for Lutma. And then the next step, which hopefully I will be reporting to you in the next opportunity, is that we need an infrastructure for community interaction. So we need to build an infrastructure to foster collaboration among everyone interested in contributing to the FrameNet model. So thank you very much. It was a pleasure to be here.
Thank you, Tiago. Tiago, yeah. Nowadays, yeah, as you said in your talk, nowadays there seems to be irreconcilable dispute between data-driven and curation-oriented researchers. Yeah, and Tiago makes the claim that this dispute is not irreconcilable, and supports such a claim with a plan for developing a multilingual, multimodal, and multicentric net frame. And he also demonstrates software tools built for lending feasibility for the proposed plan, namely the FrameNet Brasil WebTool and Lutma, a frame maker tool. Yeah, thank you, Tiago. Is there any question for Tiago's talk? Hello? Hello?
Hi, I'm here. Hi.
Yeah, okay. Yeah. It's my turn there. If I just want to put forward a very simple question.
Yes, please, go ahead.
Yeah, Tiago, it seems that what you employed as a tool, what you called the FrameNet Brasil WebTool and Lutma, to beginners, they are. They seem to be very complicated to deal with. Yeah, to handle. I'm wondering if you are planning to add a guideline. A guideline, something like that, a guide to guidance, especially the postgraduates or doctorate to handle this tool. Yeah, I want your idea.
Mm-hmm. That's a good question. So the FrameNet Brazil WebTool, it's more, it's actually more complicated. It requires some experience with annotation. So we produce some tutorials for the textual part of the annotation, so the linguistic annotation that were provided to the teams joining the shared annotation task. But all those teams had a kind of a similar characteristic because all of them were already building FrameNets, or they wanted to start. So they had some background on FrameNet building and frame semantics. But for Lutma, we also have step-by-step guidance in the form of coach boxes or text tutorials, and also on the video tutorials, which are very, very detailed. And they actually walk through people step by step on what they should look at while building the tool. So the idea for Lutma is to turn the tool into an algorithm process, right? So you always have yes and no questions. So it's very parameterized. Okay.
Okay, thank you. Yeah.
Okay.
Is there any other
questions? This is Mark. This is Mark
Turner.
Indeed here. Yeah, this is I. So Tiago, this is my question. As you know, there is only a very beginning experimentation with Chinese FrameNet, but we have wonderful connections at many elite Chinese universities, especially Hunan Normal University. So could you just coach us a little on what the first organizational and institutional steps would be to create not only Chinese FrameNet, but Chinese FrameNet as a main player in global frame?
So Mark, I think that there are two separate or complementary paths in this way. So when it comes to the annotation, right? So teams can volunteer to join the shared annotation task and contribute with their annotations to first the TED Talk, and then there will be other texts to be annotated. And the second step is, for example, if people want to teach frame building, right? Or to their students, or motivate people to engage in this kind of semantic representation building. With Lutma, you no longer need to build any kind of software infrastructure prior to start teaching, right? It's an online tool. So you had this experience with your students. People just log in and then they can start using. So it's also I think that there is one interesting part because to some extent, Lutma made the FrameNet building process more democratic, you know, so people can contribute regardless of the fact that they have a lab or they have established software infrastructure or server infrastructure, because everything is there. And as I said, you can access it from your phone. So I think that starting with spreading the word on how to build frames and that everyone can do it is a great start.